Thank you for introducing me. My name is Gert Hengeveld. I'm going to talk about going component driven. This is a talk, somewhat of an entry level talk, so no real in-depth tech, although I am completely open to answering any questions that might come up, even the more technical ones. But without further ado, let's get started. So going component driven, essentially, as a front-end developer, what you're often tasked with is taking some designs, screens of designs of screens such as these, and converting those into HTML pages, React apps, Angular apps, doesn't really matter. And well, that sometimes, like if you drill down, the process that you typically take there is to start drilling down into these screens to figure out how to decompose it and how to best build it. Take this one, for example. This is a screen of the Chromatic web app that happens to be an app that I'm working on. And you can quickly start to take it apart, right? You first start taking it apart. You have things like a header, a sidebar, a build header, a build summary, and some comments on this particular screen. Well, oftentimes, of course, you're probably building a new feature on a screen, or you're building a new screen within an existing app. So you're not going to be building all of this from scratch, but that's the environment that you're working in. Let's drill down a little bit further. Say you have... Oh, that's...
You don't see your screen.
Let me recap then, because I have to share my screen. Yeah, that's a bit different from what I'm actually used to. So I'm actually going to go back and share, not this desktop. Sorry about that. This desktop. That's more like it, right?
Perfect.
Good thing I did have the chat view opened. All right, so going component driven. What that's about is about decomposing screens. So say you are a front-end developer and you get tasked of building screens and pages. So this is what you might get as a deliverable from a designer, a bunch of screens. So, and what you do is you start drilling down in these screens. So for example, take this example where you have a build screen from Chromatic. So this is the app that I'm working on. So these are actual designs. This is just like a sketch file. It's enormous. So you start drilling down further, and you can start to identify some elements, right? Header, sidebar, build header, build summary, and comments in this case. So then you take a step further, and you can drill down even more. Let's take a look at this build summary here. This is the point where you can start to pick out individual components that you typically reuse across screens and features and pages. So say these cardinal numbers or buttons, like the canonical example, the status bar that lives on this page, badges and avatars. Those are all reusable components. And I mean, this is the stuff that you deal with in day-to-day life as a front-end developer, right? It's nothing new there, but let me tell you, this whole UI development, it's just a game of composition. So now that you've drilled down into your design, identifying individual components, perhaps your designer has actually already done that and built these drilled down for you and given you the design of individual components. And then your job starts to recompose all those components to form features and screens and pages in your app or website. So this is me, I'm Gert Hengeveld. I'm a software engineer at Chromatic. Chromatic is mostly known as the company behind Storybook. So if you happen to know Storybook, you might be familiar with that. Otherwise, I'll show it later. And Chromatic, we also build our own software as a service platform that essentially provides a whole workflow around Storybook. So around working with Storybook. If you'd like to know more about this subject, about going component-driven development, you can always follow me on Twitter. I often tweet about everything related to front-end development, UI engineering, component-driven development. So modern user interfaces, they are not only just built from components, they are assembled from components. That's the trend. Like we're more and more just relying on the components already existing in like a design system or a component library or whatever. And then it's our job to take those components and build new screens, new features inside an already existing app. That's the typical use case. Well, this has various benefits, such as that the quality of your work can improve because you get to verify that the individual components work in various scenarios. You don't just tackle the best case scenario, you tackle also the error scenarios and such. Efficiency, you obviously can reuse all these components. Like that's the whole benefit of working in a component-driven way, reusing them in various places so you don't have to build every screen from scratch. Then speed, you can actually parallelize the development of components across people within your team, but also across teams, which is a pretty big deal for big companies which have multiple software engineering teams working together to build a plethora of apps that all have to look familiar and similar and preferably use the exact same components all over the place, right? And durability, you get to pinpoint bugs at component level. So if you have a bug, it's easier to drill down into your component tree and figure out where the issue lives exactly in your component tree, and then debug that one component that you have already pinpointed. But building components, it's complicated. It's not an easy job, right? So you get to deal with flaky data in your app. So say you have a web app and you're building a new component within that app. In order to get your component in a particular state, you often have to click through the app to trigger some particular scenario, like an error case or a loading state or something like that. And reproducing that state can be pretty hard. Sometimes even impossible. Like maybe you have to like make changes in your database or something like that to break stuff. You have to deal with tangled business logic. Like if you develop within an app itself, you have to deal with the context of having routing or other like context of state that live within your app. Say a user is signed in or is not signed in. If you are doing it manually, you would have to, like if you're developing a component within the app, you would have to sign in and then test it there and then sign out again to test it there, right? That's a lot of work, and it gets increasingly complex as you have more business logic intertwined with your components. And then there is the issue of unfinished APIs, or essentially just waiting for backend developers to finish their side of the job, or the other way around, of course, happens as well. But if you're, as a front-end developer, building a new component and you have to have the data structure or the data itself in place already, and you're not the one whose job it is to figure out how to build that, then you get to wait around, right? So what then after would happen is that you spend a week building something and then 2 weeks doing nothing on that particular feature. And then after 2 weeks, you have to get back into whatever you were doing before. So that context switching is annoying. All right, so this is where Storybook comes in. So Storybook is a front-end tool for building user interface components faster and easier. It does that by allowing you to build those components in isolation. So basically a component sandbox, that's what we call it. And then catalog all the various components that you have within your app or within even the entire company, and all their various states. And I'll get to what the state is in a moment. And the Storybook is great and pretty unique, actually, in the sense that it works with every view layer, meaning every UI library, such as React, Angular, Ember, just HTML5, web components, even React Native. So right, it works with all of those systems. So it's trying to not like force you in a particular direction there. And sneak peek, by the way, these add-ons that you can install, they can soon be installed right from within Storybook. We're working on an add-on gallery, just like kind of similar to what Visual Studio Code does. You can search for add-ons. We promote particular add-ons, saying these are the most popular ones, and one-click install, and you have an add-on in your Storybook. All right, so building components in isolation, essentially what that means is you write your code in your editor, VS Code, or some IDE that you're using. And what happens is that as soon as you save your code file, the canvas or the sandbox, if you will, in Storybook reloads automatically and displays the current state of that component as it lives in the code. Which is great because you don't have to deal with the entire context of the rest of the app. You can just focus on this one component. And cataloging variants and states is represented in the tree view in the catalog of your Storybook. So say you have this graph component and it has three different states, like a default state, which is typically like your ideal scenario, and an empty state, which in which case you don't have any data, and some normalized states in this particular example, which that depends on what your story is about, your component is about. All right, so going component driven means that you start from building these components in a bottom-up approach. Then you combine these components to form bigger components. So let me say very clearly that it is not the idea of Storybook to only be building these add-on components, say a button or some toggle or some other kind of very small thing. No, the idea is that you use these components to build up bigger components. So you could have the entire page header in there, which consists of other components such as a search bar, which consists of an input field and a button, right? Or the logo or the navigation menu. That's all part of the header. Well, so that way you compose your components together to build bigger components. And finally, you even go so far as to build entire pages in Storybook. So that's what we do at Chromatic. We have stories in our Storybook for all of the pages in our app, meaning that I can click through our Storybook and see the entire scope of what the project is about, really, without even booting the actual app. So finally, you assemble your app using these components, these page components or screen components, and you inject the actual data in there, and then you have like a full-fledged app, right? That's the idea. And Storybook kickstarts this workflow by allowing you to first develop these components in isolation. So with your team, you build this component library, and I'm saying that is not just small components, but actual screens and such as well. Those are also in your component library. And then you assemble your app from those components. So let's look at an example of what it looks like in Storybook. This is a typical stories file. So it's like a button.stories.js file that you would typically write when you're using Storybook. So that starts with a title, which actually represents the path to a component. So you can create a tree structure in Storybook, and you do that by separating a path with slashes. And then you have, in this case, 3 stories. Notice that, by the way, this is just a JavaScript module file, right? It has some imports, some exports, and that's it. There is no particular Storybook API anymore. That used to be there. We used to have a thing called stories of, which was very particular to Storybook. We went a step further and we introduced something called component story format, which is essentially, it's a file format, which is, it's just vanilla JavaScript. And we intentionally made it that way so that this component story format can be used by more tools than just Storybook. And that's actually what's happening. There's integrations with various design tooling. I believe InVision design system or something. They are using something like that. There is webcomponents.dev, which is like an online IDE for web components, and also other kinds of components libraries that use CSF. So you can use this file for more than just your describing your storybook. But anyway, what ends up where this ends up is in the tree view in your storybook. So you would end up with something like this: a button with 3 stories underneath, and then the canvas that renders that particular story. Someone previously mentioned, like he was obviously a kind of a Storybook power user, but said like, hey, can't I just write a for loop, because you're just repeating the same thing 3 times over with only the appearance property changing. That's true. So if you are a Storybook power user, you would typically actually use something called Storybook args to do this. With Storybook args, you essentially write kind of like a blueprint for your story, and then you make copies of it and inject different props each time for each of them. So you get to describe your stories in data rather than in JSX, like here. So that's kind of a power feature. But if you're interested in that, Google for Storybook args and you will find it. All right, so let's talk about these component variants, aka stories. There is a bunch of things that you can use this for. There's like, you previously saw this example with a primary and secondary appearance of a button, which is just like variations on the theme, like color-wise or such. But there is way more that you could consider here. So there's various states that a component can be in, like it's a loading state, or it's disabled, or something is in progress because you just clicked the button, or it's in an error state, or say you have an accept deny thing, or an expanded collapse because it's an expandable component, right? That depends, of course, on your component, but there's plenty of things to think about here. And then take it one step further, you have to think about, you get to think about the edge cases that this component could have. So long or short text, what happens if you pass in a very long text into a particular component? How does the text wrapping work? Or does it like truncate or something like that? Big or small images, this is the same thing. Do you scale the image in a way, or do you crop it, or what happens? Extreme numbers, so say something takes a number, what happens if you pass in a negative number, or 0, or like a million? What happens, right? Missing data, that can be like the user has just signed up and he doesn't have any data in the system, so there is nothing to display. That was an early example you saw with the graph, right? Or even missing data in the sense that it's still loading, right? That might also, that's kind of a different thing. Special characters, so you get to deal with char sets and like Chinese and left to right and right to left text, right? That's something that you could consider. And then there's context. So a component, like while you develop it in Storybook, it lives in isolation, but in practice, like in the app, it lives in a certain context, right? So a component might display differently based on whether it's used in some standalone fashion or composed within another component, or you have to deal with the fact that your component is different based on whether a user is signed in or not, or the language or location of the user, or whether this user is offline, or it's a first-time user, like I mentioned. So there's a bunch of things that you can consider. And what's worse, I would say, is there's endless combinations of these things, right? And if you are used to writing unit tests for your code, it's a very similar thought process. It's like, oh, I have to take care of all these edge cases. I write a unit test for each of these edge cases. It is very similar when you're writing stories. So let's look at an example. Say you have this default version of a page header, and then there is a loading state, right? but also something with a very long title. I just passed in a very long text. What happens? Well, I don't think this looks very pretty, so maybe we want to have to do something about this. I don't know, maybe change the scaling of the text or crop it after 3 lines, or I don't know what. Here's an example from our own storybook. So you get to see what happens when you start combining states, right? So there is this one tooltip which uses other components inside. So there is, on each tooltip, there is 3 lines, each of them using a status icon, the dot, right? The colored dot. So sure, everything might be green, that's fine. But what happens when like stuff is still in progress or stuff is not completed? Or in this scenario, there is something with regards to the context. Because in Chromatic, you have the option to sign in with GitHub or the option to sign in with GitLab or with Bitbucket. But GitLab is special in the sense that pull requests on GitLab are called merge requests. So for this particular component, we actually have a variation for GitLab specifically, which says an MR check rather than a PR check, because it's about merge requests rather than pull requests. Right? That's a kind of context that you could consider. All right, so now you start composing components to create screens. So here's an example, an actual example from our code base. This is the pull request screen within Chromatic. So you see in the top left here that we have this pull request directory, and there's a whole bunch of components underneath. So that's how we built up this screen. We built it up by creating new components that are particular to this screen, and only in the end do we have a pull request screen where it all comes together. So this tooltip you just saw was one of those things. There's a pull request check tooltip right here. It's one of those. So in the screen, we're not obviously going to repeat all of those variations again. Typically, we take like the best case scenario or in a couple variations, such as the loading version or something like that. But that's how we also get to test the whole screen as like in various states and variations, right? So the loading version of the whole screen, or when there is some activity or there is no activity on this screen. Or it's a first-time user, so they get shown some explainer, like a tooltip. Or there's comments on this page, and there's versions where the change set, where there is a change or not. Right? There's a ton of variations that you can have. All right, so when you get to the details of implementing this, you might run into various issues. So I made an example with React, but this applies typically to other frameworks as well. But what if my component has internal state? How do you deal with that? Because what you should want to do is make stories for each of the variations of the component. But if the state lives within the component, how do you deal with that? How do you make a story for each variation? Well, what you do is you take that component apart. You create a presentational component, which only renders itself based on a set of properties, props, or whatever it's called in a different library. And then you have a container component around it that keeps track of the state and then passes that along to the underlying component. So here we have a collapsible component, which keeps some internal state on whether it's collapsed or not. And then we have a collapsible view, which is a presentational component, which does nothing but render something based on its props. And now the trick is to write stories only for the presentational component. So the presentational component is something you can easily write a story for because it's purely based on props. And then the collapsible, you might be thinking, okay, what happens to the container component? That's where like a unit test comes in, right? Jest or something like that. You use jest for something, to test those things. All right, so what if my component uses global state or context? So that is very typical if you use a global state manager such as Redux or MobX or one of the other gazillion variations there, or something like a routing framework, React Router or Angular, whatever router they use, right? So it relies on some sort of a global state. Well, the trick there is to wrap your stories in the decorator so that you can provide that context to the underlying component. However, that context is a fake context. So we just pass mock data in there. So that, say I have a provider for React Router, I can pass in a fake URL in there, right? To say what path are we currently on. Of course, that depends on the component whether or not it needs that data in the first place. So here's an example of using decorators to do that. If you want to know more, you can read that at the documentation. So teams all around the world write thousands of stories. We ourselves at Chromatic, we have some 16 or 1700 stories in our code base. There are teams out there with like a multiple of those, and it's used all over the world and quite successfully. I mean, it's a very big problem. However, what happens is that covering all the permutations of the components, that's like a lot of work. So say you have those 1500 stories in your Storybook code base. How are you going to test it, right? How are you going to manually click through each of those stories every time you make a change and do like QA before a release? No, that would be pretty impossible actually, because what happens is, say you have hundreds of components in your Storybook, then you like it expands into thousands of stories, and then you might want to test against multiple browsers, right? Or viewports. You have mobile and desktop and such, right? It gets out of hand real quickly. Like, this is not something you can do manually. So what starts to happen if you don't do the proper QA there is that bug slip through. So say I have the same component and it lives on 3 screens, and I make a change to that component, and well, previously everything was fine, but I made the change, and I look at the first screen and say, okay, that looks good. And then the second screen, it looks good. And before I did the release, I looked at those 2 screens and was, okay, good, let's ship it. However, there was a third screen that I didn't consider when doing manual QA, and that one's broken. And it takes a customer to actually report that to us, right? It's not a situation you want to be in. I mean, most companies don't, at least. So the solution there is to do visual regression testing. Visual regression testing is essentially taking screenshots of the component before and after each change. And then you don't take just the screenshot of the one component that you worked on. No, you also take screenshots of all the other places where this component lives. So all the like the composite components and screens and pages. And then you can compare them pixel by pixel to see what changed in there. So what actually happens here is you write stories, but you get tests for free. You get these tests automatically. And that's exactly what component story format is for, to get these tests for free. So now you can say, okay, you can have an automatic check that compares all these screenshots, says, okay, first one, this looks good, this one looks good, and this one doesn't. Of course, the system won't be able to say whether it's good or not. That's a manual thing, but it will just present you with all the things that have changed, and then you get to say, okay, this looks good and this doesn't, because it still takes a human eye to verify whether or not something is a good change or not. And this is exactly what Chromatic does. So Chromatic automatically tests your whole storybook to detect these visual changes. And then you get to approve all the various changes as a sanity check before merging and shipping your changes. And there's more. because UI development is teamwork, right? It's not just me as a single developer doing this stuff. There is designers that want to make corrections. There is QA personnel that should actually be part of the development cycle, but typically only like look at a staging environment, and that's when it's already too late, actually. Product owners or product managers, they want to check for the deliverables, right? They want to know what's up and what they can tell their customers, saying, hey, this stuff shipped in the recent release. And everyone wants to be aware of various new features because we probably have to support it over the long haul, right? So there's this additional thing where you also, with Chromatic, you get to compare across branches. So you can visualize pull requests. Just like you have a pull request in GitHub where you can compare code before and after or across branches before merging to see what's the difference between, like, what will actually happen if you merge this pull request. You now can do that also with screenshots. You see exactly what happens. And you can have your team review that stuff and approve it before merging it. And have a status badge on your pull request that says, okay, all the tests are passed and it's been approved by a team member. So going component driven, to recap, it's all about building one component at a time and then combining these components and finally assemble screens and pages. And then you integrate these pages. These pages are just full components or screens, whatever you want to call them, and you integrate them into your app by injecting the actual data. This is it. If you'd like to know more about that, look at componentdriven.org. I'm Gert Hengeveld, and thank you for watching. And now probably someone should take over.
Yes, thank you very much, Gert.
Welcome.
Well done. I suppose Dylan should take over. So I'm checking out.
Great. Can you hear me okay, Andy?
Yes, I can, Dylan.
Great. I'm going to share my screen and I'll start the video and get started.
Great. We can see you now. And we can
Awesome.
see your screen. So perfect.
Great. Thank you.
Yes.
Okay. So thank you all very much for having me. I'm really excited to talk to you all about Pipedream. We'll go over just a brief context for what Pipedream is and kind of where it fits in the front end stack. And then I'll just go through the slides as quickly as I can so we can get to the demo. So a bit about me and the Pipedream team. I'm a co-founder. There are actually 8 co-founders of Pipedream, believe it or not. I call myself a product hacker. Really just what that means is I'm a product manager and software engineer and data analyst kind of all in one. That's a title I developed for my team at Yahoo, where we did similar things, but kind of wear a lot of hats as a co-founder. Mostly I work on the developer advocacy side of Pipedream and a few other things. I'm formerly a teacher. I taught data analytics at Berkeley for some time, and I was a data scientist before that. So our team, like I mentioned, we had 8 co-founders. We've worked together for close to 10 years, and we worked on a lot of high-scale HTTP systems in advertising specifically. So our team comes from this background of developing really high throughput data pipelines and dealing with a lot of HTTP requests at scale. So that was part of the context why we decided to work on an integration platform like Pipedream. And we launched publicly just about a year ago at this point in October 2019. So the goals for the presentation today, I want y'all to learn exactly what Pipedream is, and hopefully you'll see a few ways you can use it in your stack. So as an integration platform, it doesn't fit in directly to your front-end environment, but sits in the background and operates on an API level, runs asynchronous workflows to let you integrate your data that you collect from users with third-party apps. We'll go through a lot of examples for how that works. We're going to build a few workflows so you actually see how Pipedream works in practice. And then I know I'm going to forget things. I know I'm not going to be able to cover all the powerful features of the platform. So I put a bunch of resources at the end of these slides so that when we're done, you can actually follow those links to docs. We have a growing community, so you can ask us questions one-on-one, and hopefully we can chat more. So fundamentally, Pipedream is an integration platform. And if you've used tools like Zapier, If This Then That, Integromat, or many more in this space, you'll be familiar with kind of what that means. But I want to go into this in detail so everyone's on the same page. Integration platforms fundamentally automate workflows, just a set of steps, usually between apps or within a single app. So they're typically event-driven. When an event occurs in some service, like GitHub, for example, I want to trigger a workflow. GitHub Actions, for example, is another great automation workflow platform, right? So there's all these platforms coming up to solve these automation use cases. And integration platforms specifically usually deal with integrations between applications. So they'll typically abstract the connection to these third-party apps so that you don't have to deal with an OAuth integration or really even the API level yourself, right? Typically, the API calls are often abstracted from you, so you don't even have to learn how that API works. So just a few examples of these, this is a common use case where I upload a file to Google Drive and I want to get an email with a link to that file. Every time someone tweets, I want to save that tweet to a Google Sheet for further analysis. Every day I can run a SQL query against my Postgres database, send its results to Slack. And this generic use case of whenever I receive an HTTP request, I can save that payload to some storage service like Amazon S3. So, these integration platforms like Zapier, IFT, and Integromat, and others, and Pipedream, we solve all these use cases and more. I want to talk about what makes Pipedream unique, though, because we have this philosophy that I'll dig into of being an integration platform for developers specifically, and I'll show you what that means. So this is the best graphic that we use to summarize how Pipedream works. Again, as an integration platform, we receive events from third-party applications or common interfaces like HTTP, email, or scheduled timer. The cool thing about Pipedream is we put code first. And so where other integration platforms abstract, again, the API calls, the OAuth integrations, and you have no access to how that works, Pipedream actually puts that code, we put that code first and foremost. So when you build a workflow, and you'll see this when we get into the demo, you have full code level control over even all of the pre-built actions that we provide. So Pipedream wants to make it easy for you to integrate these apps. We have thousands of pre-built actions across now 300 plus apps, but you get to see the code. The code is all JavaScript, and you can edit that to solve your use case. So if the pre-built action doesn't do exactly what you want, you can see how it works. You can modify it. But we're still providing that abstraction layer that integration platforms provide to you. So again, we're handling the OAuth integration. We have a mechanism for storing API keys and passing those securely to your execution environment so that you can make authenticated API calls to all these services. So I just want to dig in one level and reiterate some of these ideas. For Pipedream, I shouldn't have to write code to build a workflow. We still believe that these pre-built actions, these components, should provide the 90% use case of what you need. If you need to just send an email every time you get a star on your GitHub repo, this is an example we'll show off in a moment, you shouldn't have to write any code to do that, right? Those common use cases should be solved for you. But the point is that you can write code, and that's what makes Pipedream special. We don't hide anything from you. We want you to see behind the covers, be able to modify that code as necessary. When you do write code, it should be easy. So Pipedream is a hosted serverless platform. Many of the ideas behind Pipedream were influenced by platforms like Lambda, Google Cloud Functions, and the typical functions as a service platform. So we believe that serverless provides this really easy to use environment for developers, especially if you're not familiar with the backend or these functions as a service tool. We provide a UI wrapper around that. And Pipedream workflows are very easy to test and deploy. So we'll go through a few of these cycles so you see how that works. Again, everything is JavaScript right now. We plan to support Python and other runtimes, but right now, workflows are authored in Node.js. And you can require any NPM package just by actually putting that require statement in your code. There's no package.json or other configuration logic you have. Everything is detected at runtime. So you require a package, you have access to that package in your execution environment. Our integrations are open source, and this is a pretty powerful thing that we're starting to see a lot of traction on. We have a lot of members of our community who are actually contributing new integrations or modifying existing ones to improve them. So I'll show you our GitHub where all our integrations are provided, but these things like actions, like I've talked about, to abstract some API call to a third-party service, or what we call event sources, which are the mechanism for how we source new events from a third-party app, so the triggers. We'll see how this works. All these things are open source, so you can see the code, you can modify it, you can contribute new ones. As a developer platform, we want to make sure that we provide, again, these abstractions that help you solve very complex use cases. So we have a built-in key value store. Now you can use things like FaunaDB, DynamoDB, Mongo, MySQL, Postgres. We have integrations for all these other database or hosted data stores. But we want you to be able to quickly get things done in Pipedream. Commonly, you have to store state within a workflow to track data across execution. So the built-in key value store solves that. We also have advanced concurrency and rate limiting controls. For example, it's very common that you need to apply serialization to a workflow so that only one execution of a workflow runs at any given time, because again, you're working with state and it's a distributed system. You have guarantees you need to apply such that that state holds a certain value at a given point in time. Therefore, serialization and other rate limiting controls can help you manage how your workflow is invoked when you have a high throughput workflow and you need those controls. These are typical of cloud platforms. So AWS has integrations with SQS and other services that enable this, but it's not as easy. And the point is we want to make these common use cases that arise for relatively complex workflows. We want to make those easy. We also think that low volume workflow should be free. So many of these use cases, right? You have a cron job that runs once a day. We don't want to immediately push you to the paid tier. So we have a pretty generous free tier. And I'll show you the docs and limits around that. There are some basic limits in the free tier. And then we actually launched with just a free tier to get feedback from developers, but the paid tier is coming actually in the next few weeks. So we'll announce more about that in our community and via email. So before we dive into the demos, I wanted to give you context for where I think Pipedream fits into most front-end stacks, just to give you context for ways in which you might use Pipedream on your own. So fundamentally, since Pipedream workflows are a lot like serverless functions, we see a lot of use cases for HTTP-driven workflows or APIs, where you send a workflow an HTTP request from your client. You can do things as advanced as validate JWTs or control authentication for your users to ensure that the request that comes in is authenticated. Run some work against a third-party service or just run some basic Node.js code. And then optionally, you have the ability to return an HTTP response to the client. Pipedream excels at unidirectional workflows. So a request comes in, and then we do some work that doesn't involve responding to the client. But you can build APIs in Pipedream. And again, we have documentation to show you how that works. I won't go into that today, but it's in the reference. I believe that Pipedream is perhaps the simplest way to run code on a schedule, to run cron jobs. I'll show you a hopefully less than 30-second demo on how that works, just to give you a taste of how you can run a cron job on Pipedream and how easy it is. And then the other use case, which we'll go into, is given that we're an integration platform, and we abstract all of these connections between apps and the authentication layer, Pipedream excels at handling data from third-party apps that you typically have to handle on your own HTTP server by receiving the incoming webhook, or for services that don't support webhooks, you typically have to pull the API for new events. All of this we abstract for the integrations we provide. And so we're adding more every day. Again, if you see an integration that we do not support, you have the ability to add that yourself, or you can talk to us and we can pair on that integration. But fundamentally, we're abstracting your need to manage a service that handles this incoming data from third-party services. So for this growing list of integrations, we support that out of the box. So I want to actually get into the demo. I'll quit the presentation and we can dive in. I mentioned this concept of event sources. Event sources are Pipedream's mechanism for sourcing events from some service like GitHub, Dropbox, Slack, Fauna, okay? Now, event sources ideally work instantly. If the source service supports webhooks, our event sources will actually make that API call to create the webhook programmatically on your behalf, set it up to send those webhooks directly to the Pipedream event source, and then simply emit the events for you to process. And those events can trigger Pipedream workflows. We actually have a REST API and an SSC interface for you to consume those events as well. We won't talk about that too much, but essentially event sources are this abstraction that run a little bit of code on your behalf to configure that webhook. Or if the service doesn't support webhooks, like I mentioned, then we have a mechanism to run these event sources on a small frequency, like every 5 or 15 minutes. And then to receive events, we keep track of what events have already been emitted by the source and only emit new events to you. The point is that you only get new events, and those events are triggering Pipedream workflows that you've built to actually run whatever actions that you want. So event sources just abstract the collection of events from some source service. I've got a couple here, an RSS event source that just pulls an RSS feed every 15 minutes and emits new items as they appear in the feed. Okay, and if I click on these events over here, see I am generating all these example events from this feed. I see just the basic data about the GUID, the actual link, and the title of the post. So you can plug in whatever RSS feed URL you want to watch into this, and you can emit new items as they appear in that feed so that you don't have to pull that service. We have a font, for those of you who've used FaunaDB, it's a great hosted database. We have an event source to actually emit changes or new items in a collection. So that's kind of cool as well. That also pulls Fauna, since they don't have a webhook interface to do exactly what we want to trigger items on new collections. But you can set up one of those. And again, every time a new item is added or updated in the Fauna collection, you'd get a new event here. I want to show you end-to-end how to create a new event source. And I'll use one from GitHub. So I've got this random repo here. And let's say I want to track every time an individual person stars my repo. So if I go back here, I've selected GitHub as the app. The source, I get a bunch of these. Okay, most of these are instant because GitHub supports webhooks on most repo events. I'm gonna scroll down to new stars. Connect my GitHub account. I've already connected a GitHub account. If you hadn't, this would actually open up the OAuth authorization flow and direct you to allow Pipedream's OAuth application access to your account to create webhooks. And then you would have your account authenticated. So I chose my existing account. You can link multiple GitHub accounts and choose from any one of those. And then the repo, we actually list the repos in your account that that authenticated account has access to. I'll select my brand new repo and I'll create my source. And once that's created, notice that it's waiting for an event because I don't yet have any stars in this repo. So it's waiting for someone to star it. I see the HTTP endpoint URL that has been configured for this event source. And again, behind the scenes, Pipedream has actually sent a request to GitHub to create a webhook on that repo to send new star events to this event source. So if I go here and I star the repo, I now see this new event arrive. We provide a nice summary that's bespoke to the event in question. So these are new stars. It says Dilberger starred that repo. And then I get the full payload of what GitHub sent me. Okay, so all the information on the repo, the person who started, and everything I might need to work with that event. So let me quickly show you a couple other things. I get logs on all the activities. So incoming HTTP requests would show up here. I did a little work here. You don't need to worry about too much. This is during the component creation stage. This is showing me we created the webhook, we generate a random secret, and that just shows the initial logs for the event source creation. The thing I want to show you most is this configuration tab. So this shows me the basic configuration I set up when I created the source, my linked account, the repo I chose. But this code is your event source. Okay, so this is all we do. Now the platform obviously has a mechanism to run this code, but all this is a Node.js module of a specific format. And we call these things components, actually. We took inspiration from React and Vue because we believe that components are one of the easiest ways to declare this logic for these Pipedream backend components. So the event source is the thing that actually emits event, but in the abstract, the actual code behind the scenes, we call components. In the future, we plan to support different types of components. Okay, so event sources are the main type of component now. But this model we want to extend to all the other types of objects in our system. But if you're familiar with components, this is actually relatively easy to read. We have these basic name, version, description properties. Components accept props. So there's an app prop that notifies Pipedream of what app is this event source tied to. We have the repo name. That's actually declared in our app file, which provides a set of shared methods and props for all of our GitHub components. We have hooks. So this activate hook is what actually ran when I created the component. And that's the thing that created the webhook in GitHub. I have a deactivate hook as well that would tear down that webhook if I deleted the component. And the run method is the thing that actually does work on incoming events. It receives an event, it checks the signature, and then this $emit, in the context of components, this refers to the current component. And this $emit emits all that information that we saw back here. So we have a full component API doc that I'll show you later on our GitHub repo, but components are pretty simple to understand. And there are some components that are complex because the logic for actually sourcing events from that service is quite complex. But for the most part, components are as simple as that. We create a webhook, we receive the webhook, we validate the event, and we emit it. So now I want to show you how we actually do useful things on these event sources. So event sources is the way we get data into the system, but how do I actually run workflows on these? So I can scroll down and click this create workflow button. This creates a workflow that has that event source as its trigger step. So I'll talk a lot about workflows because they are the core object of our system, but every workflow is just a sequence of steps, the first step of which is our trigger step. So all workflows are triggered on some type of event. In this case, it's new stars. In other cases, it's an HTTP request or a cron schedule. I'll show you those in a sec. But I've got my trigger step already because I created the workflow from my event source. I'll go ahead and deploy. We have keyboard shortcuts, so I did that. I can deploy my workflow to memorialize that. And let's take a look up here. So the workflow I want to run, I can set a title. I want to email me when someone stars my repo. Okay, so I set a title. Shows me I'm the owner. The current version, you can see all the versions you've deployed revert back to an old version. By default, for free users, my workflow template is public. My data is always private. I'll show you what that means. And you can always set your workflow to private, okay? We want to encourage a broad distribution of these. We want to allow you to share these. So again, for free users, workflows are public by default. I can always set it private. And my event data is always private. So let me actually add a step. I want to email me when someone starts my repo. So let's click on this plus step. These actions are what makes Pipedream very powerful. Again, I mentioned we don't want you to have to write code, and we're going to write very little code today. We have thousands of these actions that provide these functions, much like an integration platform you've used before. So add a row to a Google Sheet, send an HTTP request, use Twilio to send an SMS. All these functions are pre-built for you to use. Send yourself an email is the action that I want. Now I could search if I didn't see, these are just the top actions on our platform, but you can see we have actions for all of these apps, and I can search for apps or specific actions by keyword here. But I'm going to choose send yourself an email. And I see a few things here, okay? Again, all actions are just Node.js code. So I see the code right here. I don't have to write that code. I can modify that code if I want to by clicking in here and customizing that action. It's equivalent of a fork, effectively. I'm not going to do that now, but you can modify that code. I just have to set the subject and the text. Now I can write any string I want in here, but I can also reference data from the incoming event. So the subject I want to be the actual username who starred my repo and what repo they starred. So I've got this object explorer down here. And if I select the event, I see all of the data from my last event that was sent. So I can just drill into the sender and select path for the login to choose the person who starred my repo. And I'm going to say starred repo. And then what's the actual repo they starred? Full name of the repo here. The text, I'll just say, check out their profile here. And then again, I'll go to this Object Explorer, look at the sender, and then find their HTML URL for their profile. I'm going to deploy that. I'm going to then send this test event. So this is the event that was sent to that event source. Any other stars that would come in would also show up here. So I have access to all this test data, and I can send the test event. And now I see on the left here, this event inspector shows incoming events. And it's selected when I press send test event, it automatically selected this event for me, but you can manually select that event. And then I see the execution details of that. I show that I sent the email. Now let's actually go to our email and take a look. Dilberger starred repo, Dilberger branded repo, check out their profile here. Okay, so pretty simple just to do this basic function. Now, I want to build this up, but I want to show you a more complex example of how to actually trigger an HTTP-driven workflow from a front-end app. Before I do that, I promised I would show you that Pipedream is the easiest way to run a cron job. So hopefully you believe me after seeing this. I'm going to go back to my workflows. This is my list of workflows here. I can select individual ones, or I can create a new workflow. When I create a new workflow from scratch, I see all the possible triggers here. There are these native interfaces like HTTP webhook, cron scheduler, email. We have an SDK that allows you to send data from JavaScript and Ruby today. I can create an event source for, again, any of the apps we saw before. I can choose from existing event sources. I'm going to choose cron scheduler. I'm going to set that to run once an hour. In this case, I'm going to run Node.js code. So that's the first action we put because, again, we want to be code forward on Pipedream. I'll select run Node.js code, and I'll just say console, sorry, I'm a terrible typer, console.log cron job. I'll deploy that. I'll send a test event, and I've just created a serverless function that can run on any schedule up to once a minute. And I can run any Node.js code or, again, any of these thousands of actions that I want. So I think this is pretty powerful. I run all these, before Pipedream, I ran all these cron jobs still on an EC2 instance, or I used, AWS Lambda with CloudWatch events. I don't know if y'all are familiar with those options, but it's still often not easy. If you know how to do it, it can be easy to use those cloud platforms, but I personally love a UI like this for configuring my cron jobs. And again, it gives you the ability to run any Node.js code or any of these actions on a timer. So let's wrap up with another slightly more complex demo. I created this beautiful application straight out of 1999 called Paw Pics, beautiful Comic Sans. This is my dog, Tito, and I'm building an app to collect dog photos from my friends. I've just got a really simple form here. It accepts a name of a dog and a file to upload, okay? So this app is not complex, but the point here is to show you how to send data from a form or whatever mechanism you have to trigger HTTP requests in your front end, how to send those to Pipedream, and how to work with that for a slightly more complex workflow. So I put the action URL here for a workflow URL that I created last night. I'm just gonna start this from scratch and create a new workflow. So I'm gonna go back to my list of workflows, click new workflow, select an HTTP trigger in this case. We automatically generate, just like in the GitHub example, and that was abstracted from you, but here we automatically generate an HTTP endpoint that is specific to your workflow. And you can copy this, and I'm gonna put this as the new action URL in my CodePen. And now I'm gonna actually upload a new photo. Tito. And I'll choose another great photo of Tito from the beach. And I'll submit that. Now, I wanted to keep this redirect here because by default, what happened here was we sent an HTTP request with that form data. And one cool thing that Pipedream does when we receive HTTP requests, for common formats like JSON and multi-part form data, we parse that into a JavaScript object that you have access to in the event data. So I showed how to use that event data before, but I wasn't explicit about all the things you have access to up here. When I select this event, it shows me all of the event data that came in with the HTTP metadata. But the cool thing is, again, Pipedream has formatted the body into a JavaScript object for easy use. So I see my form param here, name Tito, and the file, we have this mechanism that is documented that you can take a look at more, but basically the TLDR is that file that I uploaded, that image, that gets delivered to this S3 bucket that we host with a unique URL that is signed such that only you have access. And this file is hosted for 30 minutes and is deleted immediately after. And so to actually use this file in your workflow, you have access to it now by just this URL. And you can download it. You actually have access to the file system in Pipedream workflows. You can read our docs about that. Or I can just send this to some service that accepts a URL as a file upload. And that's what I'm gonna do. In this workflow, I'm gonna send this image to store in Cloudinary, just a simple file hosting service. I'm gonna record the name and the image URL, the Cloudinary image URL here, because that's where I'm saving this long-term in Cloudinary. And I'm gonna send myself a Slack message. So, you know, this workflow is a little bit of a toy, right? But I wanna be clear that we support all these types of integrations with all the tools you're used to, all the cloud platforms. You can do quite a bit from Pipedream that is of a production grade. And I just wanted to show you this workflow because it's relatively simple and it shows off the key parts of Pipedream. But yeah, I just want to be clear that Pipedream, we do not consider Pipedream a toy. It can be used for personal use cases, but it can be used at high scale. And we really want to drive those use cases home. So I'll start again by sending this image to Cloudinary. I'm going to search for Cloudinary, and I see an action here to upload a media asset. I'll select that. This action is much more complex than the ones we've seen so far. I have first a required parameter that is the file to upload, but that's it. And I think that'll just upload it to the root directory of Cloudinary, not in any folder. I have access though to all these other params that I can use that map to the Cloudinary API. So here we use Cloudinary's NPM package, And if present, we pass all of those options to the upload method. But again, you don't need to worry about any of that. You have access to the code. You don't need to modify it. So right now, I'm going to connect my Cloudinary account. Again, I've already connected an account previously. And then I'm going to select that URL. Cloudinary, luckily, will accept a local file path, a data URI, or a remote HTTP URL like here. So I've got that. Additionally, I want to upload this to the doggos folder. So I'm just going to type that string in. I am going to deploy. And then Pipedream has the option to replay an event that I'd sent before. And that's functionality that I'm going to use here. I don't have a test event like we had for GitHub in this case that contains the file upload or the name of the dog. So I'm just going to rely on the previous event I sent, hover over it, I press that replay button, and it sent the event through the workflow again. So if I refresh this, then we should see the new photo. Internet's a little slow today, I apologize. Great, there is the beach photo. Okay, let's go back to the workflow. Let me show you what we're gonna do next. So this event is selected. I see all of this response data from Cloudinary, and I'll show you exactly how that works. I awaited the response here. I think this one, yeah, it set the upload response variable there. I waited that response, and then I returned the upload response from Cloudinary. So I get access to, for example, the URL that Cloudinary is now hosting that file on. So I'm going to use, I have the option to copy that value or copy that path. And in this case, I'm going to copy the path because I want to use the variable steps.cloudinary upload media asset $return value.secure URL. So what's going on specifically here is every step of your workflow is named. If your step returns data, we put that into this $return value property. This is the object in this case, with all of these properties. So I have access to what we call these step exports in future steps. So I've uploaded this to Cloudinary. Next, since workflows are a linear sequence of steps, next I can do something else. So again, I'm gonna add the URL and the name of the dog to a Google Sheet. I'm gonna connect Google Sheets. My spreadsheet ID I get from the URL. Eventually, like we saw for event sources, we want these to just list the spreadsheets you have access to in your account, as opposed to you having to manually enter these. So that'll be coming soon. The first column I want to add is the name of the pup. And next is the image URL. So I've got two columns here. When I add a single row to a spreadsheet, this action expects columns of data. And so first is the name. So I'll select that path. And then next, I can click this plus button to add a new column. I copied over the URL that I chose, but that's okay because, again, I have access to the step exports from that Cloudinary step here in my Object Explorer. So if I click Steps, Cloudinary, return value, again, I see the data from the last event, so it's super easy to identify what field I actually want. I will select that path, and I've populated that. I wasn't explicit about this, but we use two curly braces to surround variable names for variable interpolation inside of these step parameters. And that's how I added both plain text and variables in the last step, just to make that explicit. Sheet 1 is the name of my sheet. And I'll deploy, and I'm going to replay this event one more time to now, it'll upload it to Cloudinary again. That's fine for testing. And it should take that Cloudinary URL and then pop it in the Google Sheet. Great. So now the last step is to send it to Slack. I've got this doggo Slack channel. I will go back to my workflow, search for Slack, send a message is the first action I see. again, I've previously connected that Slack account. Text is someone uploaded a new photo of, I'll put the dog's name, and then I'll put the URL to the Cloudinary step so that it shows up in Slack. Slack should render the contents of this URL. The channel, doggos. Okay, so let's see if this works end to end. Replay the event. I wish I'd made a mistake because our error handling is actually pretty cool. And we display the full stack trace. If you click on the event that you had an error on, it would move you down to the actual event that threw the error. So we should do that sometime, build a more complex workflow that we can actually make mistakes on. And I see the message in Slack. So I want to go back to the presentation really quickly just to wrap up. We're big on, like I mentioned, open sourcing our integrations so that you have access to all of the code. Again, actions you can see directly inside of the platform, but I want to show you our actual GitHub repo where we host all event sources. So Pipedream HQ/Pipedream. We've got a lot of stuff. We've got our public docs. Our components right now, again, are the event sources that I showed you earlier. So I can search GitHub, new star, and I'll find the code that I showed you for that GitHub star event source. But all of the event sources have nice readmes as well. Okay, so we try to document all this stuff quite well. You can take a look at the component API docs and our quick start for more about how to create your own event sources. So if you sign up for Pipedream and you create an event source and you notice that the app that you want to listen for new events from is not listed, you can go through the quick start and actually learn, well, how do I create an event source for this? And we're improving the developer experience. So we're really hoping for your feedback here. If you'd like to help contribute to these, you can also just open up an issue in GitHub and then we can work through the event source again on our own as the Pipedream team, or we can help support you to create one. We've got all these other feature requests and bugs as well. So we track all this stuff in GitHub. We use GitHub discussions as a Q&A forum. And additionally, we have a Slack channel that we sit in and will respond to questions in. We've got a bunch of resources here for other more advanced features we didn't get to cover today. So a link to our root docs. And then all of these are worth checking out for more advanced things that you typically find when you build a more complex workflow. We've got a CLI and a REST API as well. We've got a SQL service where you can actually send JSON data to. We'll programmatically create tables that map to the schema of that data, and then you can query that via SQL. It's a pretty cool feature when you want to run basic analytics on incoming webhook data or other data from your client. And then information on the specific limits I mentioned of the free tier, and then notes on security. We take security very seriously because we're an integration platform where we do all these integrations. So any questions you have about that, let us know. I put the example workflows and all the code that I referenced today here, and hopefully we'll share these slides out later. That's it. Thank you very much.